Welcome back. This is the Tutor Wizard. I'm Adrian. Please subscribe right here. We're doing mathematical modeling. This is chapter 2, discrete time models. 2.7 is going to be the last part where we do just one equation, and then section 2.8 is going to deal with systems of difference equations and then the stability of systems of difference equations. So the one last thing I want to talk about is, and to remind you, is solving nonlinear difference equations is difficult in general. So we have a systematic way of solving, which is also horrible, but at least a systematic way of solving linear ones for certain forms, most forms, especially first order. So what we're going to do is, long story short, we're going to discuss this lecture on methods of transforming nonlinear equations into linear equivalent linear forms. Then we can solve the linear version and then backtrack to get the original variable. Let's do that. These are the two main ones we're going to do: Riccati and homogeneous. A different, slightly different context of homogeneous. Let's get to it. All right, type 1 is going to be order 1 homogeneous Riccati equations. Basically, this is the form usually they give you, but before we start that, and then they say use this substitution, and then you're off to the races. Like, I don't quite understand what the heck is going on here. So I claim that this is going to try and rectify some nonlinear difference equations for us. So first of all, this is an xt plus 1, xt plus 1, and then I have xt and xt. Solve this equation for xt plus 1. And I get this. So this is the general nonlinear term that you're going to get. It's basically a hyperbola. We have xt over xt, so we could use long division. This is basically going to be the graph of a hyperbola in the continuous form. But what the point being is, this is nonlinear. And so even for simplicity, so you can see it in the classes that I'm teaching, most of the time we're going to do constant coefficients. We won't even let these guys be variables of t. So if I let those two things be constants, this is the general thing that you're going to get. I give you this and I say, find the explicit solution to this. You're like, I thought we didn't have to do nonlinear ones. Well, it's definitely nonlinear. And what you can do is multiply both sides by this thing, and then you're going to get something like this. Then we're going to have to do a couple more little clever tricks. The book will usually just say, then use this substitution and solve for zt. You're like, well, wait a second. So let's take this form, or this form, I'm going to the general form. I'll turn it into this, then do the clever trick, then make the substitution z, and then we'll do an example. Let's get to it. This is the substitution, fill your boots. Well, maybe explain it a little bit more. All right, what we're going to do is, this is the type of nonlinear equation you're given. And so what I'm going to do is try and put it in a nice form, and here's how you would systematically do this every time, and then we'll do the substitution at the end. First of all, what I'm going to do is write this all on one side and equals 0, homogeneous. So the first thing I'm going to do is multiply both sides by xt p plus p of t. What do I get? I get xt plus 1, xt plus p of t equals negative q of t for convenience, xt. Left brackets should equal the number of right brackets. Now I'm going to distribute that in there to make it look like the purple boxed form that I gave originally, that the book always starts with. Then what we're going to get is, if and only if I have xt plus 1, xt plus p of t, they said first, xt plus 1, plus I'm going to bring that one over, q of t times xt equals 0. That's the one they gave you, but this is the difference, nonlinear difference equation you'd be given originally, I would imagine. Anyways, I imagine a lot of things. So when I have that, now what am I going to do? Now what I'm cleverly going to do is multiply both sides. Again, they don't subtly point this out, but I'm going to multiply both sides by 1 over xt plus 1 xt. What is that going to do for me? If I do this, I'll go slow. I'm multiplying that, so I'm going to distribute it in there. This I'm going to get 1. So 1 plus p of t times xt plus 1 and xt plus 1, and that term will cancel, so I'm going to have a 1 over xt plus q of t. When I distribute this into here, the xt and the xt will cancel this time, and I have 1 over xt plus 1 equals 0. This is the Riccati form now. What Riccati noticed was, in this form, if I transform this to this guy, actually now, this is how they should state it, but too bad we got it now. It's ours. Patent. I don't think you can patent these things, but anyways, this is the point of what we're now doing. And he says, oh, if I made zt equal 1 over t, then in particular zt plus 1 would be 1 over t plus 1, and we're going to get, now using the substitution, zt equals 1 over t, and therefore zt plus 1 equals 1 over xt plus 1. Using these in there, we're going to get the Riccati form, which is going to give us 1 plus p of t zt plus q of t zt plus 1 equals 0. And this is now linear in first order in zt. Now I can use the techniques of the previous videos to systematically solve this linear equation for zt, and then we can back substitute the xt's. Actually, before we do an example, let's summarize this. This is the hot mess. You'll be given a nonlinear first order difference equation. Hopefully you'll be praying that, as I will be, that these are constants at least, coefficients. Once we have that, what we're going to do is simplify. I bring everything up and I write it in the form that the book usually gives it, Riccati type 1, homogeneous. Then what we're going to do is we divide by xt plus 1 xt, and we get this form, and then we can see what Riccati's seeing, hopefully, that we have a 1 over xt and a 1 over xt plus 1. So if I just made that z, then I would have linear in z. So we write it like this, and we notice now, yes, to nail it on the head, if I simplify and move everything over, this is now zt plus 1 equals negative p over t q over t zt minus 1 over q of t. If those are numbers specifically, we're going to get constant coefficient linear first order. So if this is a number and this is a number, what we get is zt plus 1 equals a zt plus b. The systematic ones that we've done, that's exactly what I'm going to do in a second, because this Pillow type difference equation has an awfully similar form to this one, and so therefore it is specifically Riccati type. That'll be the example we do. But the point being is, this clever transformation takes a nonlinear first order equation in x and turns it into a linear first order equation in z. Then we can systematically solve for z and then back substitute for the reciprocal relationship between z and x. That means that xt, of course, is also 1 over zt. Same reason as when we have a hyperbola xy equals 1. That means y equals 1 over x, or x equals 1 over y, whichever one you want. There's enough rope to hang yourself. Be careful. All right, example 1 is going to be the Pillow equation. I don't know if I pronounced that right. The French people are like, it wasn't even close. He's Anglo-Saxon. It's not my fault. This, we've got xt plus 1 is alpha xt plus or over 1 plus beta xt. Where they actually get this from is they're trying to solve in the continuous time x prime equals a x of t 1 minus x of t, something like this, the classic logistic equation. And what he does is he realizes that the solution explicitly using ODEs, we're going to do that in chapter 3, and then we'll discuss this a little bit more, but he gets this equation where essentially he can write it as this horrible form of 1 over 1 plus e to the something, something, something. I don't want to get into it too much. But then what he cleverly notices as he's doing that, just to tell the story, he says, well, what if I put t plus 1 in there? Even though this is continuous time, he says, what if I make this discrete time? And then what he does is he puts that in there and simplifies everything cleverly, and he gets an e to the a xt, I think, and then 1 plus some horrible number, which was b over a e to the a minus 1, something like this, and then he gets xt. So he says, oh, I'll just make this beta, and I'll make this alpha, and the Pillow equation. So this is where it came from. It came from the continuous time stamp, and then he says, from this I can create a nonlinear discrete relation between these guys also. So that's the story of where it came from. Now that we have that, what we're going to do is notice that it's Riccati type 1. Is it? Let's check. First of all, this is what you're given. Then I'm going to put it into the form, divide by xt plus 1 xt, and then see if we can solve by making the substitution. What we're going to get is if and only if I have xt plus 1, 1 plus beta xt minus alpha xt equals 0. I bring this one up, I brought that one over. Now I'm going to simplify it and make it look like we did in the first scene. So what is that going to give me? That's going to give me technically xt plus 1, I'll go slow, plus beta xt plus 1 xt minus alpha xt equals 0. And then what I'm going to do is technically in the when we did in the form, this was a oneer. So we'll divide beta is going to be, I'm going to assume that beta is positive and alpha is positive, so we're not dividing by 0. And then what that's going to give me is if and only if, simplifying this and dividing through 1 over beta, we get xt plus 1, 1 over beta, plus xt plus 1 xt minus alpha over beta xt equals 0, or specifically the way they wrote it was xt plus 1 xt plus 1 over beta xt plus 1 plus negative alpha over beta xt equals 0. And this is the form that the book will usually give you. If you have where you have one term has the product of both of them, another term has just xt plus 1, another term just has xt, we can now make the substitution zt is 1 over xt. And that's what we're going to do next. Let's move it up and do that substitution. But first of all, this is the Pillow equation. This is how we notice that it's a Riccati form, and then we're going to divide by xt plus 1 xt, and then make the substitution zt equals 1 over xt. So now that I move that up magically with editing, every time I say that, he doesn't edit it, so then I can't tell anymore. But what we're going to get is, we're going to divide by that guy. I'll show you that too. So what happens, I get a 1 plus 1 over beta xt, and xt plus, or xt plus 1 xt cancels. So I'm going to get 1 over xt plus negative alpha over beta xt, and xt will cancel. So I'm going to get 1 over xt plus 1 equals 0. Once I have this, I can now make the substitution for these guys, and that's zt equals 1 over xt, and zt plus 1 therefore is 1 over xt plus 1. If I make that substitution, what am I going to get? I'm going to get 1 plus 1 over beta zt plus negative alpha over beta zt plus 1 equals 0. Once I do that, I'm going to put it in a nice form, and we're going to get zt plus 1 alpha over beta, move this to the other side, is equal to 1 over beta zt plus 1, or zt plus 1 is dividing by beta over alpha. We're going to get, this is equal to 1 over alpha zt plus beta over alpha. And now you can see this is a constant coefficient linear first order difference equation from our nonlinear difference equation. Now we can solve this systematically for z, and then put in the relationship that zt is 1 over xt, and if and only if, of course, xt is 1 over zt. So now let's do that quickly. If you want to see, all I'm going to do is give you, therefore, this is the general solution to the zt, and then I'm going to put in xt is 1 over zt, and then we'll have the general solutions. If you want to see how I found the general solution to this one, go watch our previous video on constant coefficients, non-homogeneous first order difference equations. That's a mouthful. Watch the other video. All right. Nobody said this would be easy, but we've got a method of doing it. First of all, I take this nonlinear difference equation, I transform it into a linear first order equation. This one happens to have constant coefficients even. And then I can use the general solution, the techniques of finding the general solution to constant coefficient first order non-homogeneous difference equations. I can get this solution. Look at the previous video. This is explicitly how we get it. C1 is just the constant we get for the general solution when we don't know what the initial condition is. Don't worry about it too much. You should know how to find this form by now, hopefully, if you're taking one of my courses. Then what we do with this form is, cleverly, because it turned it into linear and z, we have the moral is we have a systematic way of finding the solution explicitly. Then what we do is cleverly back substitute. If zt was 1 over xt, xt is now 1 over zt, and basically this looks horrible, but all we did was reciprocate both of these expressions. And so xt explicitly now, even though this was non-linear in xt, we now have the explicit solution of this nonlinear equation using Riccati's clever substitution. And then what that does for us, I know there's a lot of moving parts in your shell shock at this time by the time we did the substitution and then found this solution and then substituted to get the original xt. The point of that being is we now have an explicit solution. If you let t go to infinity, we see that if you find the equilibrium for this one, it's going to be either alpha minus 1 over beta or 0. So what that says is either 0 is asymptotically stable if alpha equals 1, and alpha minus 1 over beta, the unique equilibrium, is asymptotically stable if alpha is not equal to 1. The point being is I want to do this long-term analysis of my system. When it's nonlinear and you have Riccati form, you can turn it into linear, find the general solution of the linear, make the substitution for the nonlinear one, and then I can use mathematical analysis to find out whether this equilibrium is stable or unstable. It definitely is. Let's do the second type, first order non-homogeneous Riccati. All right, for type 2, we're going to do order 1 non-homogeneous Riccati. We'll keep a constant coefficient for the most part, but they like to do the general form. So first of all, this is what they throw at you. They're saying it's going to be Riccati in this form, but that's just never usually what I would give it to you or what the question is going to give it to you in its original form. So let's remind ourselves of that first. They're going to say this is the Riccati form, obviously non-homogeneous because we replaced the 0 with an f of t where f is non-zero identically. It's the same form where we have t plus 1 t in one term, just a t plus 1 in the other term, and then just a xt in this term, and now it's non-homogeneous. But where it comes from is solve back for xt plus 1 in this equation, you're going to get something that looks like this. In most of the things that we're going to deal with in an introductory course, I'm going to let all of these functions be constant numbers so we can get a handle on this. And then this is probably what I'm going to throw at you originally in the question. Now what's the difference? In the homogeneous type, the m is not there. So now what you have is you have this hyperbolic expression, this nonlinear expression again, but now you have the constant term on the top and on the bottom. This is the big difference. And the big difference is the substitution. You have to be a little bit more clever. What we're going to do is use this to turn this one into, this time, a second order homogeneous difference equation in Z. Let's do that. Fun math is not an oxymoron. Order 2, basically what we're doing is, or type 2, order 1 non-homogeneous Riccati equations. Now what we're doing is replacing this. What we're going to cleverly do is, now that we see that, this is the form we're starting with, but it's actually going to be that nonlinear difference equation you'll start with. You turn it into this. Then what do? Well, Riccati says now what you're going to do is actually make, it's actually xt plus p of t. Those guys we're going to let be a clever substitution, zt plus 1 over zt. Why does that help us? This is the substitution he actually uses. Well, then you also have to remember we need the other index. We've got 2 indices in there, t and t plus 1. So then I have to also say to myself, well, using this Riccati substitution, xt plus 1 plus p of t will be zt plus 2 over zt plus 1. Then what do? Now that I have this guy and this guy, I can put them into here. So xt plus 1 plus p of t, or xt plus 1 is this guy minus p of t, so I put that here. I put xt here. I put xt plus 1 here. I put xt there. I make the substitution. I FOIL everything out. You can do this for practice. And then essentially once I simplify it, long story short, we get this equation, which is now second order homogeneous in zt. And then again, watch the previous video. We have a systematic method of solving second order constant or even non-constant coefficients. Even if they're non-constant coefficients, for most of the stuff we're going to do, it will be constant coefficients. So these will be numbers, which makes it even better. And then we're off to the races. Let's do at least one example where I do specifically this. These will be constants. All right, let's do an example of this non-homogeneous Riccati. Of course, as promised, for me, especially when I'm doing videos, and for you if you're doing the homework or quizzes and stuff, I gave myself constant coefficients. So what does this actually say? Just quickly, p of t is 4, q of t is 1, and f of t is our non-homogeneous part, which is -6. They're all numbers. Then what I'm going to do with this is you're going to have to memorize the formula or the substitution. But what I'm doing is I'm now making the substitution xt equals zt plus 1 over zt minus 4, because that's my p of t this time. And then we also need xt plus 1, therefore, is zt plus 2 over zt minus 4. Putting those into here, what are we going to get? We're going to get zt plus 1 over zt minus 4 times zt plus 2 over zt plus 1 minus 4 plus 4 times zt plus 1, no, that's xt plus 1, t plus 2 over zt plus 1 minus 4 plus zt plus 1 over zt minus 4 equals -6. You can either FOIL all that out or use the formula now. They say simplify, and what does that say? We should get zt plus 2 plus, what was it? f of t minus p of t. I have some practice, but that's what it's going to be. Zt plus 1, and then minus, did I write it down correctly? Yes. I had to check even. See, you're not allowed to check on the exams. Minus, it's going to be f of t plus q of t p of t times zt equals 0. From this, now either we FOIL everything out or I use the formula, and I think I've made a typo in the formula. It's a t plus 1 in the p of t. It won't matter when I use constant coefficients, but if I use non-constant coefficients, it won't. But what's the formula? It says it's going to turn it into zt plus 2 plus, it should be q of t minus p of t plus 1, not p of t in the formula in the last one. Like anyone cares, or like I'm just praying I never get one of these anyways, so it won't matter. And then minus, we get f of t plus q of t p of t. Those should all be t's. Zt equals 0. For us, what do I get specifically? Long story short, now that I've got it right, zt plus 2 is plus q minus p. So 1 minus 4 zt plus 1 minus, what do we get? It should be f of t negative 6 plus q of t times p of t, 4 zt equals 0. What does that give me? That gives me a constant coefficient second order difference equation, which is homogeneous in zt. Let's move that up and solve that. All right, example 2 is solve xt plus 1 xt plus 4 xt plus 1 plus xt equals 0, or equals negative 6, not 0 this time. We're going to make it non-homogeneous Riccati type. What am I going to do? Long story short, we did the transformation, and now you can see I have second order constant coefficient homogeneous in zt. What do I have? I have the characteristic polynomial immediately is going to be r squared minus 3r plus 2. When does that equal 0? If and only if, what am I going to get? R plus 1, no, r minus 1, and r minus 2 equals 0. This is unstable. We have our largest real root, which is 2, which means it's non-oscillating and unstable. That's a different video. But this says our general solution to this is going to be zt is equal to c1 1 to the t plus c2 2 to the t. And I can't help myself. 1 to the t is always 1, so this is just c1 plus c2 2 to the t. And therefore, that's the general solution. How do I find the xt's? Now, because of all that clever substitution and all the work is done, now what we're going to do is we see that the general solution xt is zt plus 1 over zt minus p of t. In this case, that's going to be, I'm not going to clean it up but because I'm lazy, but this is going to be c1 plus c2 2 to the t plus 1 over c1 plus c2 2 to the t minus 4 is p of t. So this allows us to get the general solution to xt, even though it was a nonlinear difference equation. Let's do one more type called homogeneous form of zt plus 1 over zt. Xt plus 1 over xt. Let's just do it and then we'll see. All right, type 3, or the last type I'm going to discuss. I have a few more, but they get, if you haven't enjoyed the substitutions already, you won't like the ones that I spared you. So I'll pin a PDF or something with a couple much nastier general substitutions for nonlinear guys. Nobody said it would be easy, but the point is they're nonlinear and I can't solve them. Using some clever trick, I can turn it into a linear one, hopefully, or a simpler equation, and then solve from there and backtrack. Last one we're going to do is going to be called homogeneous of the form. We're not going to use t, usually we're going to use autonomous, but either way, in the general form is they say if I can write the overall expression in xt plus 1 and xt as a function of the ratio of xt plus 1 xt equals 0, that's why they're calling it homogeneous, then we can make the substitution zt is this guy, and this time we don't even need the minus p over t like we did last time, so the substitution is a little nicer. And then they say it's going to transform it to this form. Can you see what they're really saying here? And that was as hard in this one to see what they're talking about. I'm going to be given something like this: xt plus 1 equals, let's say, g of xt, and we'll get rid of the autonomous, or we'll get rid of t, so it's autonomous right away. Then what they're saying is, well, let's make that homogeneous. So they'll bring everything to one side. Xt plus 1 minus g of xt equals 0. And then they divide both sides by 1 over xt. if when I do that move, I get something that is all xt plus 1 over xt right there, and then minus g of xt over xt equals 0. If I can write that nicely as a function of xt plus 1 in every term over xt, then we can make the substitution this and write it in the form of just having the single variable zt instead of having xt plus 1 and xt. The problem with this is, and you'll see right away when I do one, sometimes when this depending on what this function is, you still get nonlinear in the new variable, which is going to be what happens, but it's fairly trivial, so then we can use that to back substitute in this case anyways. But they get complicated as the moral, but at least we have a method of solving some of these first order homogeneous of this type to turn it into a simpler form and then find the solutions. Let's do an example. All right, so how do we see that we're going to have a homogeneous form that they're saying to make the substitution? This one I can see that we're going to get quadratic, but the difference here is in the Riccati ones you have a xt plus 1 xt term, you have a just xt plus 1 term, and you have a just xt term, whether it's homogeneous or not. You got to see it in your minds, and we write it down for everybody else. Now what I see is you're going to get a quadratic term, but in general, you're going to have, I want this one to be gone, so it'll be linear. That'll be a different story for another video. But if I have t plus 1 and t terms and mixed terms and just xt terms, what am I looking for? You're looking for squared, one that has both of them, and then the other one being squared. Now what I'm going to do with that actually to see that it's actually this homogeneous type is we have to do this. Multiply both sides by 1 over xt squared. What does that give me? That's going to give me xt plus 1 over xt squared minus 3 xt plus 1 xt over xt, cancel, plus 2 xt squared over xt squared, cancel, equals 0. That's what you have to see first. The clever trick is usually I'm dividing out so that I can get this more linear looking form or this homogeneous expression now. And now what you can see is from this, I move everything to one side, I make a clever substitution, and now I can see I can write it as this is going to be f of xt plus 1 over xt equals 0. Where what is f, so that you can see what the theory is saying. F of x is x squared minus 3x plus 2. Long story short, what am I saying? I can make the substitution zt is xt plus 1 over xt, and we're going to get zt squared minus 3zt plus 2 equals 0. The problem is with this one specifically, you're going to want to hope that this term is gone and then you'll get linear first order. But what we've got is constant coefficient, but this is quadratic in z still, so this is nonlinear in z. Luckily, this isn't too bad, so I'm going to solve this equation. What do? This says we're going to have zt minus 1 or zt minus 2 is equal to 0. And that says zt equals 1 or zt equals 2. In this case specifically, it's going to help me. Why does that help me? Because now I can put this equals 1 or this equals 2. And what does that give me? That tells me that xt plus 1 over xt is equal to 1 or xt plus 1 over xt is equal to 2. I'll move it up and then we can solve those two because these are, once I move these over, these are constant coefficient linear first order homogeneous equations. Fill your boots. So recapping, I had homogeneous. What I did was I divided by xt squared. Then we get xt plus 1 over xt squared minus 3xt over plus 1 over xt plus 2. I can make this clever substitution now. That gives me a quadratic in z. Solving this quadratic in z tells me that zt was 1 or zt equals 2. Luckily, reverse engineering now, we know that zt is xt plus 1 over xt, so I can get these two equations. These are both first order homogeneous. This is where alpha equals, or where the constant equals 1. This is where the constant is equal to 2. How do we solve these? If I have initial conditions, this one tells me that that's steady state. Put an equilibrium there. What am I going to get? X star equals X star. So this tells me that your steady state is going to be xt is going to be alpha for t greater than or equal to 0. It's never going to change. Alpha, 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 alpha. In this sequence, what are we going to get? We're going to get that xt is equal to alpha 2 to the t. So these are the infinitely many solutions you're going to get to this difference equation. Cleverly, what we did was we made a substitution, solve that quadratic. Hopefully, if it's linear, then you won't even have to do the quadratic business. Solve for zt, make the substitution back, solve for the xt, find this explicit solution, and then we have solve this horrible nonlinear difference equation in xt. Please subscribe right here. I'll see you next time.